Hello, good morning or afternoon, good evening. A little bit of a sound check here, quick sound check. There's probably a loud hum because I am currently running the heater in the garage. But other than that, let me know how my voice is sounding, and I'll be getting started in approximately 2.5 minutes. Hello, happy Monday. Welcome to another session of the Coding Train. My name is Dan. I will be your choo-choo conductor for today's session. I'm still setting up a few things here and there. Last time I forgot to record my session to disk. So I am going to make sure that I do that this time, and I want you to think about today's sponsor of the Coding Train as I go and set those settings. Today's sponsor is CuriosityStream. Let's see, how come that did not open? OBS 64. Oh, OBS is already running. Launch anyway. Yes. Okay, thank you. And now I am going to hit start recording. And there we go. All right, so boy am I unsure about what's happening in the world of the Coding Train, but I am preparing. I don't know where it is. Maybe this is it. This here is a stool actually. It's like one of these weird stools that like you sit on and it wobbles and it's supposed to be good for your back. But I am now hereby proclaiming that this is a reset button. It's a giant reset button. And very soon it will be 2022. And I am going to place my bell on top of the reset button, and I can't do it now. The ball will drop onto the bell. We'll make that sound, and everything's gonna be reset in the year 2022 because this, this has really been quite a difficult, I know, year, 2 years for so many people. Just for me, speaking personally, just a really difficult month of December. And I haven't been able to sort of keep up with the pace of sort of Coding Train activities like I would really like to, but I'm finishing up a whole bunch of things, and I have this clear path ahead of me. So this is the time, by the way, if you ever wanted to get in touch with like your suggestion of what you think the coding train should really be. Should it really just be daily live streams every day? Should it be more sequenced video tutorials? Should it be project videos? Should it have high production value, low production value? Should it have a brand new website that allows you to share all the things you're making based on the Coding Train videos back? Should we be doing more things on social media? Should Coding Train have a TikTok? I'm thinking about all these things and ramping up my plans to activate all of the cars on the train and the various different engines and the components. It's all going to happen in 2022. But here I am, still in 2021, just eking out one more live stream. There's going to be another one. At some point, I really would like to do my annual holiday/New Year's Processing Foundation telethon to support the work of the Processing Foundation. I think this is not official yet. This is unofficial. This is like a little unofficial pre-announcement announcement. I think it's going to happen after the Christmas holiday, but before New Year's this year. I don't think I can get it together to do it this week or next. So most likely my the holiday live stream, which will be a New Year live stream launching the New Year of the Coding Train, will happen probably, I'm going to guess, December 29th or 30th or 31st. One of those dates. If you want to be the first to know when I've scheduled it, you should sign up for the Coding Train Discord. I just pressed a button, and I don't know if that message is going to go into the chat. Didn't seem to do it, but it's codingtrain.com, thecodingtrain.com/discord, discord.gg/codingtrain. Somebody will put it in the chat. Hi, Peter. Glad that you're here catching the stream. But what am I talking about? If you want to be the first to know about when this special end-of-year, New Year, Coding Train telethon spectacular will happen, maybe I'll even break out my ukulele to sing a New Year song. Would you like to write that song, the lyrics of that song? Get in touch, because I got nothing. I got nothing. If you want to be the first to know, sign up for the Discord, because the Discord, it has this new feature. Let's see if I can even show it to you. I'm going to open up Discord here on my computing machine that you cannot see just yet. Oh no! Okay, wait. This is fine. I have to log in. Everything's going to be fine. It's got this magic QR code thing. So this is really what I should be doing on a live stream. I should be logging into things. Start talking. I'm talking already. I don't need to start talking, Discord. Why are you reminding me? If I had a co-host, I wouldn't have to just continuously speak the entire time. I should be good with the silence, or I need more music going on. Now let me just do this little special trick thing that I'm going to do. Then let me go back to, the Coding Train. I'm really doing something very important, but you can't see it, because otherwise it will reveal all of my Coding Train, oh my God, secrets. We wouldn't want to do that. Now, okay, yes. No. I got one more button to press. Boy, I really should have prepared this. Did I tell you about today's sponsor? Oh, no, look at that. Well, I'm still doing this. Hidden, Option Command I, turn this off. Oh boy, this was worth the wait, everybody. Oh, you have no idea what's coming to you. You have no idea the excitement I'm about to show you. This is a very long sound effect. Such a letdown. But you'll see here in the Coding Train Discord now has this events feature. So whenever I have a live stream event, I schedule it in the Discord, which there's a way for you to get a notification about that. You can see the YouTube link, the details about it, if it's happening now, it'll have a big happening now button. So I fully expect that there are now hundreds of thousands of viewers in real time of the Coding Train right now because of this new happening now button, thing, card, tag, Discord extravaganza. All right. So you can also just subscribe to the YouTube channel, and there's like a bell or something. It'll also give you a notification, in theory, when I schedule the next live stream. And Simon is reminding me in the member Discord, remember when you did Advent of Code on the stream? Yeah. I really want December to be like a really active month of streaming and coding and fun, but it's just not happening this year. But mark my words, streaming and coding and fun and all of that stuff is coming in next year. So what are we here to do today? If you've enjoyed my last 3 live streams, then do I have good news for you? I'm going to be continuing the project. This is kind of a new thing that I started, which is, and I'm just going to come back over here for a second, which is to work on a larger project over multiple sessions. I don't know how effective or entertaining or insightful this is. So right now, the kinds of things I do in the Coding Train are divided into sort of different buckets. And actually, one thing I might just do right now, just to talk about that for a second, is to come here to the channel. So this is great for anybody who's new today. So I have the most popular thing that I do, which YouTube likes to tell me is very popular, are these coding challenge videos from at least 4 or 5 years ago. So apparently the way that I work is I discovered something really popular that people love and want to get more of, and then kind of went and did something different. But so these are the coding challenge videos. They're sort of standalone one-off videos where I build a project. I also have, and this is kind of where what I'm kind of very much dedicated to always having, at least this feels very primary and fundamental to me. Hi, Christine in Leeds, England. Welcome to Leeds, England. Lovely to see you here. These are the sort of sequenced tutorial videos. So first of all, if you are new, or if you have a friend who's like, oh, I'd love to learn to code, or where should I start, or I'm interested in generative art, or creative coding, or JavaScript, this playlist is for total beginners. And one of the things that I have been doing, and the reason why I like having it sectioned into different videos, is because I can over time replace them. So if I look at this right now, these were, you can see like these are from 3 years ago, the sort of intro to the series and using the web editor. Then all of a sudden, oh yeah, then we still got 3 years ago. Then all of a sudden, we go and we get some videos from 6 months ago, more gray hair. So these were so out of date and old that I started to replace them, new thumbnail style. I don't know what people think of that. But then we go back and we continue, like suddenly then the video goes to 6 years ago. So definitely high on my list is anything that's 5+ years old in this sort of tutorial series I want to redo. I have been working, this is what I'm kind of focusing on today. I would like to make a video about autoencoders. Matt is saying I could probably get a co-host and songwriting help from GPT-3. Great point. Actually, that's been my sort of pet procrastination project, is playing around with a lot of the new large language models that are available through OpenAI's GPT-3. And also Hugging Face hosts a tremendous amount of different language models with lots of exciting applications, although I think it's important to be very cautious and conscientious when using these large language models. So there's a lot to say about that. Nature of Code is a big project for me in the new year. I don't know where I'm scrolling. What I was talking about, which I wanted to just sort of get off my chest here, is that standalone project videos like these, sequence tutorials, and then if I go to, live streams. So I thought there was a place where I could just see like my live stream playlist. I'm not seeing it. I'm not going to try to find that now. But that's what you're watching right now, apparently. 166 of you. Lucky, lucky, lucky people are here with me. Would you redo the game you started? Says Nico writes, would you redo the game you started with the triangles moving around the map on their own? I'm not sure what the redo them but never remove them. Yes. So this is a good point. I have no plans to ever delete any of the older videos. And in fact, another way to browse the videos is through the Coding Train website. And if I go to beginners, if you really enjoy the sort of classic Coding Train style, you can find these really ancient intro to processing tutorials, which are, even though it says 2015, I'm pretty sure these were recorded in 2012. It's just that I only got around to uploading them to YouTube all at once on July 10th, 2015. Time flies. I'm getting older too. What's that song that I'm thinking of? You're getting older, I'm getting older too? I don't know. I'm getting older. You're not. You look lovely. You look beautiful. You look younger than you ever have. And actually, the irony here is, while I'm talking to you, the viewer, I'm just staring at an image of myself. So I'm saying it to me, but really I'm saying it to you. All right, we got to get moving here. I've been alluding to it. I want to tell you about the best deal in streaming available today. Oh, anything. Think of any streaming service with any content. I have to tell you about the best deal available. Better than all of the ones you're thinking of. So how do I get to it? If I go to youtube.com/thecodingtrain and the community tab, I just made a post about it. And here it is. Holidays start early. So you've heard me talk about this before. It is the Curiosity Stream and Nebula bundle. It gives you access to all of Curiosity Stream, tons of educational documentaries, nature, science, math, just nature. Those are the ones that I love. So many amazing documentaries. And with it, you also get full access to Nebula, which is a streaming service that my content is on. You can even see here this picture. So all ad-free, if there's any, all sponsor-free. Really nice player. You've got like a Roku app and a Fire TV app, some new stuff. I think I wrote about it here. Picture-in-picture on iOS. And I stole this from Renee Ritchie, who I'm a big fan of, all for less than the cost of a USB dongle. So you can get all of the Nebula content, all of Curiosity Stream, thousands of documentaries for less than $12 a year. This is exclusive only for the holidays. It's a 42% discount, $11.59 if you sign up through the link. It's pinned in the chat. curiositystream.com/codingtrain. So if you're wondering, like, what's a way for you to support the Coding Train, actually going to that link and signing up will supports me and supports all these other wonderful creators that are on Nebula. I'll come back in the middle and just basically say what I just said now again. But if you have any requests to poke around and look at any particular content, I can make some recommendations for you. All right. Now, coming back. I am really excited about this project. Because it is one of these things, like as Simon likes to tell me, wait, I'm sorry, I'm reading the chats in multiple places. Thank you, Vivasvan. Simon likes to remind me, I have this habit, if I go to the Rainbow Topics GitHub repository, I have this habit of making these like to-do lists. Fall 2020, spring 2021, summer 2021. Notice I didn't make one for fall 2021. I was like, forget it. I just make the to-do list and don't get to anything that's on it. I think I would really like to make one for 2022 and really develop a schedule. Oh, something that I'm thinking about. Tell me what you think about this. Here's an idea for you. Think about like some cool illustration, graphic design. Twitch Tuesdays, Coding Train, Twitch Tuesdays. Like a little music bump or something. I was thinking of experimenting with streaming on Twitch, but also Tuesdays. So a little different vibe, probably some more interactive features, something I'm thinking about. But I believe, like if I just go to summer 2021, you can see all these lists of things that I want to do. And on the list, it's been there so many times, autoencoder. So Viviswan asks, what are you building today? Autoencoder, except I'm not really building it today. I am finishing it today. I have been building it. Guess what? You have about 6 to 7 hours of old content you can go back and watch. So I have been working on this autoencoder with Tensorflow.js and P5.js for the last 3 live streams. I don't think I should go past this one. And the thing that I'm thinking about doing, and I would love to hear from you, is then not on the level of, say, like 2-minute papers or some other, like 3 Blue 1 Brown is another channel that I love, Sebastian Lag, Jordan Herrod. I'm just naming YouTubers that I like. But I am thinking about what would it mean for me to do a scripted, I know, shocker, scripted video about what is an autoencoder and how to build one using Tensorflow.js and P5.js, and cut and paste, that's not the right term for edit together highlights from the live stream sessions with narration and some additional demonstration. And that could be maybe in 20 minutes. That's kind of a goal that I have. The only video that I've done anything remotely close to this is the mouse learning. Let's see if this comes up. This video, if you haven't watched it, let me just pull this up for a second. This is a video that I made that had a script, and I love you too, doo-doo venom. Okay, you just made me say doo-doo venom. That was a trick. Good job. And Andrew's asked me if I've looked at Advent of Code. So if you haven't watched this video, I would love for you to go check it out and tell me what you like or didn't like about it. But the idea here is, could I kind of have the best of both worlds? Like one of my mantras, one of the things I really try to do is show every piece of building a project, start to finish, and all of the pain and bugs and mess in between. At the same time, how many of you realistically, if you're like, I want to learn how to build an autoencoder, oh, there's 7 hours of video I could watch where at the end you get a fuzzy circle? Really have the time for that, or going to, is that really going to be useful for you? So I want to try to have the best of both worlds. That's something that I'm thinking of planning to do. Matt says, great plan. Matt Gorbet from the French. Gorbet? No, maybe? Sorry if I'm butchering your name. That I am thinking about doing. So anyway, new area of exploration. Look at all this stuff. So much stuff that I want to do. Oh, remember how I was going to do these? I have some like just videos that I recorded, and they're kind of like half edited that I never got together to finish. So much. Oh, plotter. I want to buy a plotter. So many things. I want to get a knitting machine. So much to do in 2022. I'm a poet, and I didn't even know it. All right, so let's get back to the task at hand before I take up too much time with this introduction to today's session. Thank you for everybody for being here. Let me go to terminal. I'm going to walk you through now all the pieces of the project that have already been built. So first piece is a processing sketch to generate training images for the autoencoder. And I realize that if you're totally new and haven't tuned into the last 3 live streams, the question, what is an autoencoder, might be on your mind. I'll come to that at some point, I'm sure. I won't be able to help myself. But just imagine, at least for the 1-sentence version, I'm using an autoencoder to create images in the style of an existing data set. And this here, if I run the sketch, this is now generating that existing data set. It is just a series of random circles or squares. I believe I'm making some number of them, as we will find out. I'm making 1,100 of them, so at some point it will stop. And we can see now in this data folder, here are all these images that I generated. So I'm hoping by the end of today, I can try to work with something more sophisticated. Should I try to use letter forms, color, different kinds of shapes? I'm not sure yet. More abstract patterns. Again, I don't know. But let's leave that. Ooh, fractal trees we could try. That would be kind of interesting. Learn Blender, says Akeem. Yeah, I'm kind of into this idea of learning Unreal Engine and then turning this garage into like a virtual set. I have this huge garage now. Can I make it into a volume like the Mandalorian set and just put like screens over everything instead of a green screen to just actually be this giant screen behind me? I don't have the budget for that. I'm going to need a lot of you to sign up for that Curiosity Stream bundle if I'm going to do that. And Andrea asked, are you working on a new version of the Nature of Code? And Stig writes, oh, just crack the playback speed to 28x. I hope, by the way, all of you just watch me on 2x. I mean, obviously you can't right now. Although maybe good touch. No, Touch Designer I don't think is for me. I appreciate the suggestion from Rodrigo, but probably not for me. Wait. I was talking about something. Generating images. We're doing the autoencoder. And I was talking about the Mandalorian set. Nature of Code. It was Andrea's question. Yes. So, I don't know why I'm dancing around this. I am on sabbatical starting. It's actually not I still have a lot of admin and other NYU-related responsibilities that I'll be continuing to do for the first 3 weeks of January. But my sabbatical from my teaching job begins January 24th. I'm not suddenly going to be full-time coding trained, but if I'm at best 1/5 time right now, 1/8 time right now coding trained, honestly, this month. I'm hoping to ramp up to like a quarter time, a half time, like really spend 2 or 3, like at least 2 full days per week working on coding train. I've got to, there's an expression that uses naughty language, if you will, that I'm not going to say. I have to do something or else get off the other thing. I got to do this Nature of Code book. Like it's now or forget it. Like if I don't have a new version of the Nature of Code book done in 2022, forget it. It's never going to happen. You heard it here first. Mark my words. Sign me onto the piece of paper. Everybody record this, broadcast it, put it out into the universe. I'm either going to have a new version of the Nature of Code book completed. That means you can buy it, a print version, and it will be all online for free as a website. Both of those things by the end of 2022, all with P5.js, a new chapter on neural networks. If that's not done, that's it. That project is dead. I don't think I'm going to do a Kickstarter for it, which is what I did for the first book. I think I've got enough kind of momentum with the sort of support. So those of you who are supporting the coding train, whether it is signing up for a membership, supporting the sponsors, all the other kinds of ways, just watching, tweeting, sharing, recommending it to your friends, all the things that all of you do that I so appreciate. I think that's enough to kind of keep me going in terms of Nature of Code book. Unity and Godot would be better alternatives to Unreal, says Simon. Okay, I'm going to take that advice very seriously. And thank you. Kathy wrote this really, Nicole, shader expert Nicole is in the chat. Oh, shaders! I actually really would like, I don't know if I'm qualified to do this. I got to see the great Patricio, author of the book of shaders in New York City recently, and I said, oh, thank you. I feel like that's what people sometimes like have that reaction to me, and I'm like, no, please, no, stop. Oh, no. Oh, if you insist, and then I get out my ukulele and play them a song. No? Okay. Christmas 2022 gift, yes. Okay. Nicole, thank you for your help when I stumbled through learning shaders. Thank you, of course, to Eliza and Alethea in the Curiously Minded stream. I was thinking I might like to do a little basic introduction to shaders as like similar to my intro to P5.js. But I don't know. To do that, I really have to think about how I'm kind of crediting all of the sources that I'm sort of learned from. I mean, this is something that I do throughout everything, but also like whether I'm really the right person for that. I mean, in some ways, that's the idea of the coding train. Like, I'm a beginner at this too, so let's learn together. I have to think about how to do that effectively. Okay. Yeah. Nicole, you are an expert in my eyes. But no one is. Expert is just a word that maybe we should just remove from the vocabulary here. I mean, it's nice to be an expert in something, but I feel like there's nothing wrong with being an expert. People who are experts should be celebrated for their expertise, especially in like the sciences and things that we sort of like rely on to keep our world turning and our society moving forward. But in creative coding, I like to think of all of us as expert amateurs or amateur experts. I think it's more like we're expert at being an amateur. Like that's what I am. I have decided. But I'm not saying I'm good at it, but like the thing that I like to do is try to learn the new thing and then help others learn it as well. And sometimes I fail, sometimes I succeed, who knows. Back to the AutoEncoder project. Kendry! I'm not prepared for this. Kendry Ruyon, welcome to your Coding Train membership. You have just boarded the Coding Train passengers manifest. Please make sure you sign up for Discord. Check the community tab for a post where there's a Google form that you can fill out. Make sure you link your YouTube and Discord accounts. And you also get a random number. 2022 is going to be the year that I'm going to get back to reading this book of random numbers in a logical and organized way. But your random number, Kendry, is on page 169. It is row 8,420, column 0, 1, 2, 3, 4, and the number sequence is 56029. Again, we've kind of lost a little bit of momentum on this, but we'll get it back. A bunch of you, if you're in the chat and you received one of these, please give it a shout out. But members at certain levels will receive this beautiful custom laser etched train whistle with a random number, with a random walk, according to the sequence of your random number in the random number book. Ooh, that's a mouthful. Okay. So KYDZ, I got to get to the autoencoder. It's 11:35, so I'm going to start that. But I do want to address this as an excellent question from KYDZZ. How do you see the use of your projects on websites? Either following the internet video or changing up code. I love the flock animation. Are you okay with crediting? Great question. So let me rephrase the question. And let me just create a scenario. You're a viewer of the Coding Train. You saw one of the coding challenges. Maybe, and I'm going to just go to them. And you're like, oh, this self-avoiding random walk. This pattern is perfect for this design that I've been hired to do for a movie poster or for my own personal portfolio website. I want it to be running in the background. Can I use it? So the short answer to that question is yes, with no other caveats. All of my example code is released under a very permissive license, typically the MIT license. Hopefully, it's here in the website. I think it's in the FAQ license. Here we go. MIT license. So this is a short and simple permissive license. Conditions only requiring preservation of copyright and license notices. License works, modifications, large works of each instrument are different terms without source code. So basically, you can use it for anything you want. You can modify it. You can distribute it. It can be private. You don't have to provide credit. So there's not a lot of restrictions in terms of the example code. Let me say a few things about that. It's nice if you can give credit. I appreciate it. I'm saying this less for me. I get plenty of credit. I don't need any more credit for stuff. But we live in this sort of ecosystem of creative coding, open source. Everybody's got different sort of comfort level with things being reused, not reused. So always check to see if there's a license. regardless of what the license is, I would provide credit, a reference, a thank you. I would be overly generous. I would go above and beyond whatever is required by the license. And the thing, this doesn't apply to my code examples, but you will often find artistic works that are released under an open source license. So in theory, there's no legal issue with you taking that code and using it, say, on your own website. But I do think there is something different to copying example code and remixing it for your own creative vision and taking somebody else's artistic intent and applying that within your own work without sort of proper reference and credit. So it's muddy, it's murky. Certainly there are sort of like clear scenarios like, oh look, example code under MIT license, please go forth and use. Artistic work without the source code being open source. You may not like copy that, put it out under your own name, sell it, make prints of it, sell it on your local corner store, market, or whatever kind of digital currency things people are doing these days. I don't want to get into talk about right now. And I think actually Golan Levin has a really excellent guide to this. I just want to I know where I can find this, so I'm just going to pull it up. Actually, I think I can probably show you this. Pretty sure that I keep a note to it in my syllabi. I know I do for my undergrad course that is in NYU's learning management system, which I can't pull up, but I can go to my public syllabi for my programming from A to Z course. By the way, if you're looking for some of my most recent stuff, Pablo is saying open processing now requires to give credit to all you. Yeah, so open processing is definitely a site where people are publishing both their code and their sort of creative artistic vision. And so if you're helped by the code and you provide credit, I think that's very reasonable. If you are just, if you took something on open processing and turned it in as your homework assignment for my class, I think there would be an issue, even if that's not something that's, you could be sued for, according to whatever the laws of wherever you are. Let me just go here to A to Z. Let me see if I can find the reference to Golan Levin's. Yeah, here we go. So I adapted this. It's called Statement, Use of Free and Open Source Code from Examples. This is adapted from, I'm sure, hopefully Golan Levin may have an more up-to-date one from when I adapted it from fall 2018. But I just thought this is a really useful section that is speaking of giving credit, adapted from Golan Levin, so written by Golan Levin. Be careful, it sometimes happens that an artist places the entire source code for their sketch or artwork online as a resource from which others can learn. Assignments given in new media. Arts courses are often similar. You may also discover the work of a student in some other class or school who has posted code for a project which responds to a similar assignment, or even the assignment for your class that you're taking right now. You should probably avoid this code, or at the very least be careful about approaching such code for possible reuse. If it is necessary to do so, it is best to extract the components that solve a specific technical problem, giving credit there, I would add, and rather than those parts which operates to create a poetic experience. Again, these are tricky things to define in really strict boundaries with really exact right or wrong. We're all trying our best. It's very hard. I think transparency and narrating and documenting your process is the most important thing you can do. So even if you did something that you felt like, make it your own, even if you did something that could be characterized as repurposing the poetic aspects of somebody's project into your own, if you've documented through your blog post, through code comments, through your website, your entire process of how and why you did that, then at least I think a good faith discussion around that can happen and can be corrected if their mistakes were made. So so you can hopefully, I don't know if this, let's see if this link still even works. Yeah, so this is the original policies from Golan's syllabus. I assume there's a more recent one than 2018. You can find it under my Programming from A to Z and other courses if that's helpful for you. If you have suggestions about how to phrase and write that better, boy, would I love those, because this is a very, it's like, talk about FAQs for people who are new to teaching, people who are students new to coding. I ask this question all the time and get confused myself. So, okay. Now, autoencoder, we're really going to get to this project. This is why it takes, by the way, this is why it takes 700 3-hour live streams, because I spend 45 minutes. I haven't even started working on the code for this project. How about we start now? Oh, I did. I started demonstrating. Okay, generated the training images. The next step, and let's check. I have a node, a piece of node code that runs through a series of steps. Basically, it builds the architecture of this machine learning autoencoder model. And sorry, I'm just reading KYDZZ's. This balancing act of like just having this discussion with the chat and going through this code example is quite difficult. But recreating the flock typed animation is, yeah. And so again, to be clear, I am making and releasing my examples for you to use them, and you're not required to give credit, which is different than if I had some sort of like artistic project that I was displaying that had some other kinds of intentions behind it for you and how you might reuse that. So copying my code exactly and putting it on your website is fine. That's what it's there for. Of course, you probably want to make it your own. That's the exciting part of all this. Okay. SGL, let me see if hopefully somebody in the chat can post that link. Otherwise, tweet at me or follow up after. I can try to put it in the video description later. Okay, so back to the autoencoder. The code that I've written so far basically does everything. It creates loads all those 1,100 training images. It trains the autoencoder with the training images. I'm using just the first 1,000 images to train the model. It then saves the model to a local file, because I'm going to load that model from a P5 sketch. And then it also generates test images just to sort of see. Okay, so let's run that. Let's first look at the directory, and I'm going to delete all of the output images that I generated last time to make sure this is actually working. And I'm going to run the training. Now, it was suggested to me, I think over social media, after last live stream, that I absolutely need a song to play or sing. By the way, I do have my ukulele here in the studio. It's been over a year since, where's the joy in my life that it's been well over a year since I actually even unzipped this case. I mean, there's no way this is going to be in tune. Even this is my nice one. It has a strap. It's not in tune at all. None of the chords I play will work, but we need a training song. Okay, I'm gonna have to deal with this later. But so anybody who wants to write me a training song, maybe it would go Epoch 34 out of 100, ETA 1.1, 1771 milliseconds. So this is not good. This is not good. This is not good. The loss is going down. It's at 0.06. This is very embarrassing. The voice in the back of my head always, when I start to the silliness starts to take over a little bit, is people who comment, "I would have enjoyed your video if you just would stop it with the clown act." I can't help it. That's my inner soul is a clown. It just wants to break free. I never made it to the Jacques Lecoq School of Mime in Paris. That was like my childhood dream, and I just never made it there. And now I reduced to machine learning JavaScript examples while clowning around. Getting 100 epochs was definitely too long. Yeah, Chris Sears, it should be in the style of a Rocky montage. I like that. I really don't need to let this go all the way, but especially because I already trained the model, but it's almost there, so I can let this go. All right, so we're almost there to getting this to train, and as I start to iterate and work on this more, I'm going to not, take the full 5 minutes or whatever this has been for it to train, but we're almost there. So once the model is trained, Manas asks, are you plotting the loss? So questions would have been good, so I am not. The loss value, which is the result of a loss function, is sort of summarizing the overall error of the model. How well is it at reproducing those original training images? And you can see that it's going down over time, although it kind of went up here. So one thing that I could do is analyze, like, when did it really stop? Like, clearly at epoch 34, it was quite higher than at epoch 54. But you can see somewhere around here, actually, maybe not even until like the 90, around epoch 90 or so, did it sort of stop really going down. Kathy asked a great question. It is possible to set an acceptable loss, or maybe this is a question, is it possible to set an acceptable loss before running and stop when it reaches the desired loss? That's absolutely. I could write that into the code. I'm not going to do that right now because that would be sort of an additional thing to engineer, but I would certainly encourage anyone watching to try to do that. That seems like a really interesting idea. Yeah, so again, just to emphasize, hi Michael K. I posted something on Twitter and somebody came to join the live stream. Look at this, amazing. Okay, there's so many interesting questions here. So let me address these questions by the following. So first of all, this is the output that I have now generated. Let's take a look at these images. And I'm going to just scroll through a bunch of them. So you can see I'm getting what I was hoping for, which is these kind of like squircles. They're mostly circular, but you can see the sort of corners of squares, and sometimes I got a full square, sometimes I have a full circle, sometimes I have something somewhere in between. Now, a couple things to mention about this. One, this is an incredibly trivial example, right? What I am reproducing with the autoencoder are very low resolution, simple shapes that are either only, there's really only two variables here. There's a switch, is it a square or a circle? And then there's the radius. So you can think about, this actually came to me, I think it was based on some of the chat messages, but if I go over here to the whiteboard, if I were to come over here and sort of re-explain what an autoencoder is, and again, what is an autoencoder? Go and check out the 2-minute papers autoencoder video on YouTube, where it describes an autoencoder as a copying machine, right? It's a neural network that takes an image in as an input, and the idea is we want to get that same image out as an output. That's a very easy thing to do, right? We could just, in terms of without a neural network, I just iterate over the pixels and make a new image with all the same pixels. However, the idea of an autoencoder is the data is being passed layer upon layer upon layer through a neural network, being compressed down from however many pixels to some other layer with a smaller number of nodes, and then decompressed back up. So if you think about it, I technically only need 2 nodes in this sort of center layer for what I'm doing, because one variable, right, I need to keep track of what is the size of this shape, and the other variable, is it a square or a circle? So in theory, if I go to the architecture of this autoencoder, and I look at how I've built it, right? Oh, I'm sorry, I didn't switch over. If I look at how I built it, the first layer receives, it has 256, it receives the number of pixels of the actual image, and it compresses it down. I mean, this isn't really compression. I'm just using that as kind of in a sort of metaphorical way to describe the process, although, I mean, it is compressing it, essentially, the data. 256 to 128, and then down to 8, and then back up to 128, back up to 256, and then eventually back to a full pixel image. Right, and we could do a convolutional autoencoder and a variational autoencoder, and then thank you, Astro Penguin, for answering about overfitting. So we can address that in a bit. And I feel like I was getting some good suggestions about changing what loss function I'm using, but just out of curiosity, I hate to do this. Let's add one more layer and bring it down to 2 units. And then have the decoder also have one more layer with 8 units. And let's see if I can still get it to work. And I know I said I wasn't going to do this again with 100 epochs, but I can't help it. So here we go. We are training the model again. Let's see if that loss can go down and see if we can get a mean squared error loss function for autoencoders, yeah. And Astro, let me just read Astro Penguin's comment. Overfitting is when your model doesn't just represent your data, but also your noise. It is so well trained to your data that it works very well on it, but poorly on another data set, right? You can train a model so well that it can reproduce the training data perfectly. But because it's just so locked into that training data, if the real world data has any kind of variability to it that's just not there in the training data, it's going to explode and do a terrible job. So there are lots of techniques to reduce overfitting in terms of how you collect your data set, using something called dropout, which is adding some sort of randomness and disconnecting parts of the neural network as it's learning. This seems to have settled on a loss of 0.23. I'm going to just run this again and just give it 30 epochs so we can, I think that's faster than waiting for it to get to 100. Where do I set the number of epochs? Train, here it is. So let's just train it with 30 and let that go. And Simon's reminding me that I was going to try to do this with, try to see if I could denoise some images. So I'm getting like sort of scattered here of all the different things I want to try. But it's okay, it's not even noon yet. Only spent an hour. Plays the autoencoder song. Cyber said, this is great. Cyber Gus says, it's like preparing for a math exam by memorizing the solutions to the problems, right? So like if you have like a sample test and you just memorize all the answers, but don't look at how any of the problems work, and then you got a new test, you could put all those correct answers in, but they won't match the actual problems. It's kind of a wonderful, okay. So I think we're at epoch 30. I'm just curious to see, oh, there's a lot of randomness in how well it does. I should have let it go more. I didn't realize. But let's just see what kind of images we got, even from that training. So they look pretty good. They're just much fuzzier. So this is what it was able to do with just 2 parameters. But also, I didn't let it train for as long as I could have. Nicole wants to know what is in my mug. First of all, love this mug, fellow mug, not a sponsor. You never know, though. It is coffee and oat milk. Delicious. Sometimes it is ginger tea. Depending on how I'm feeling, I'm either like a coffee and oat milk or I'm a plain ginger tea kind of fellow. That's with my fellow mug. That's me. All right. Moving along. Let's go back to, I'm reading Simon's commentary and I totally agree. Let's look at whether or not our autoencoder can effectively denoise a shape. This is, an actual application of autoencoders. What do I even mean by denoise? hold on. So I'm going to put this back to 100 epochs. And I'm going to go back and get rid of this like little layer and just leave the middle layer as having 8 units. I want to just try it with a different loss function. Is it this? Is this what I should put in here? Let's just try. A little risky here to introduce that at the moment. But OK, let's train. I'm just going to let it train. Oh, look at that. Huh. Look at that. It like, with that loss function, it's like not improving after just a few epochs. Interesting. So hold on. This will be great if that was that much of an improvement. Let's have it go just 10 epochs. Sometimes it's totally unnecessary, but I just like to delete the output just to know that I'm getting new output for sure. Let's run this for 10 epochs and see what we get. Look at that. Like basically after 2, 4, 5. Oh, no, it's still improving. Huh. Oh, it's still, this always, why does this happen to me? It's still improving. So the other time it kind of like was waffling, but let's take a look at what I've got after just 10 epochs. All right, fine. Torture me so. Go back to 50. This is one of the problems with this project is just running it again takes so long. MSE. Did I not type the right thing in? Let's let it go. We're going to let it go for. Let's actually look in the TensorFlow documentation. Where is that? Is this Tensorflow.js? I don't think so. These are all the tabs I was looking at. Ooh. Yeah, look at this. Going way down. Still going down. Oops. This is what I want. API. Oh, I want the TensorFlow.js API. Mean squared. Yeah, no, I think I got it right. Mean squared error. Now, do I want this to cast a gradient descent? The learning rate was too high. Might be getting stuck in a local minimum, the opposite of a T. All right, so that's interesting. I wonder if I should be also trying this stochastic SGD optimizer instead of Atom. But anyway, it was still, the loss even at that 50th epoch was still going down pretty consistently, although it did pop back up there. So let's take a look now at the images we generated. All right, these look really good. So what I want to see now, if I can get it to do, is denoise an image. But I'm going to go into the browser to do that. That's what we didn't get to do last time. Okay, everybody? Okay, so the next step of this was, if I run a local web server, I have a P5.js sketch, which is loading the model. That's interesting. I thought I would have to go into like the public. Oh, it's serving. It knows to serve .public. That's so funny because I have a directory in there. Okay, so this is now the P5.js sketch, which is loading that model, and I am feeding it just random noise, like a sort of Perlin-esque Perlin noise. There's always sort of discussion around whether this is true Perlin noise or not, or simplex or gradient or whatever. But this sort of cloudy noise pattern is what I'm feeding into the model, and I'm getting this shape out, meaning the model is working. And this is kind of like leading the way to what I want to really focus on today, which is a latent space walk. But before we get to that, what I would like to do is draw an image of a circle and see how it copies it, an image of a square, and then add noise and see what happens. Bear with me, or join me for this part. So I'm going to go into the sketch.js. I lost my train of thought here. And let me just do training new model. So I am going to, comment out. I think I'm just going to take out the noise thing because we don't really need that. So it'll be in the code history. Do I want to add a tag? People are going to want to find this. Well, I know where it is. So finally, I'm going to take out all of the noise stuff. And just go back to a random image and saying no loop. So if I do this, and then next image, sorry, I'm forgetting how I'm doing this. Does this work? I then put no loop in. I just want to know, this is silly, I don't need to add the no loop, but I'm just curious too. All right, forget it. Keep the no loop. Have it be a random image. Wait, sketch, sorry, hold on. What did I do? Oh, I lost this. Okay, this is what I wanted to do. So this is what it looks like when I'm feeding random noise into it. It's trying to find, and Monthnon says, we see a machine trying to find shapes in the random noise. So what I would like to do instead is, and I'm going to create a, I don't know what to call this, I'll call it input canvas. I'm going to say input canvas equals create graphics at I've done this in sort of like a weird backwards way, but bear with me. What is the size? Oh yeah, create graphics W, comma W. No, we're fine. Create graphics, I forgot I had that W value. So I'm working with 56 by 56 pixel images. And the input canvas, I'm going to say input canvas dot background. I'm going to draw a background of white. Then I'm going to say a stroke of 0, a stroke weight, and this I should essentially be matching what I did in processing. So I'm going to say a stroke weight of 16. Then I'm going to say input canvas circle, W divided by 2, W divided by 2, and just give it a radius or diameter of W divided by 3. And I'm going to say input canvas no fill. Then this is still going to be random. I'm just doing this one. The only thing I'm trying to do right now is I want to see a shape drawn with P5 on this left part. So now I should be able to, in draw, instead of rendering this input image, I should be able to say image input canvas 0, 0, and resize it up to W times W. Wait, why won't it do that? Doesn't, my variable names are terrible. Where was, okay. And then let's see if this now gives me, oh, this always happens. It's trying to import, it's trying to import something. I really have to work on my VS Code settings. Okay, good. Oh, the stroke weight. Oh, I forgot I was drawing it as a larger image than resizing it down. So this stroke weight was, you know, a bit much. Technically, it should be 16. This is very silly, but I'm just going to do this. Okay, great. So now, the idea here is that the autoencoder should take this input circle and produce an exact copy of it on the right. Now, however, what's important to note is I'm not feeding it into the autoencoder. So the next thing I want to do is feed the image into the autoencoder. So that happens here. So I'm going to need to do it by looking at the pixels. So I need to say input canvas load pixels. And then I equals 0, I is less than W times W times 4, because there's 4 elements of the pixel array per, oh, no. I'm going to have to do the multiply by 4 somewhere else. Same thing, because my input image array has W times W spots in it. But instead of a random, I want to say input canvas pixels I times 4. Yeah, that should work, because I could just take the R channel. If it's a full grayscale, like black and white image, I times 4, if the array is RGB alpha, then the R channel is 0, 4, 8, 12. And so if the I is going up 0, 1, 2, 3, I times 4 is 0, 4, 8, 12, etc. So I believe this should work. Look at that. Look at that beautiful autoencoder. It copied that shape perfectly. Now, just you wait and see. Let R equals map mouse X, which goes between 0 and width, to between 0 and width. This is the most brilliant code I've ever written in my entire life. I'm going to map this range between 0 and width. Now, hold on. Everybody just hold on a second. I'm going to blow your mind right now. To between the minimum of 0 and the maximum width. But in case I wanted to change that later, it's nice to have the map function in there. And then this should be R, which is really a diameter. So let's call it diameter. And we should see, I wonder if it never got, interesting. So this is not working as expected. I'm definitely redrawing the image, redoing the pixels into the autoencoder. Let's try a square, just out of curiosity. And also, wait, I have an idea. The range was 25 to 200. So in theory, like the only range that it learned is between 25 divided by little w and 200 divided by little w. So that might help. And I can just say input, if I'm going to do a square, input canvas, rect mode center. Let's see what happens here. I'm like suspicious that it's not, something is changing. All right, do I need to train the model? I feel like the model picked up the average radius of the circle. It does seem that way. All right, I feel like, let me just go back to what I had originally, which was I just want to make sure I'm using the right model. So let's, I'm sure it is, but let's go to where's the model saved? Oh, it's here. Today at 12, wait. It's a little bit silly, but let me, I'm going to put this back to what I started with today. So I'm just putting it back to binary cross entropy atom, even though it kind of doesn't make any sense, and 100 epochs. And I'm going to once again train this model and let it go the full 100 epochs this time. All right, everybody? The decoded images look like the average of all parameters, half circle, half square with a medium radius side. I know. So I wasn't getting that issue before, so I'm just going to let this kind of power through a longer training process and see what we get. So this will be a new, the way I have this configured is when I train the model, it saves the model in the directory of the P5 sketch, and the P5 sketch should pull that up. All right. While this model is training, and since I'm halfway through the live stream, this is a perfect time for me to do my sponsor segment. Ta-da! Today's Coding Train is brought to you by CuriosityStream. Mwah! Thank you, CuriosityStream. Now, I'm just going to repeat what I said at the beginning of the live stream, but those of you, I know most of you probably weren't here at the beginning, so guess what? I have something exciting to tell you about. It is the best deal in streaming today. So I am going to go up here, and show you something. CuriosityStream. Let's come back over here. Okay. Whoops, wrong thing. CuriosityStream. I'm signing in here. Okay, so CuriosityStream is an amazing streaming service with thousands, literally thousands of documentaries, all in so many areas related to things that I do here on the Coding Train. In particular, my favorite part of kinds of documentaries that are on, oh my God, I've got to watch this one. Whale wisdom, I love whales, are the nature documentaries. Secret Lives, there's a whole bunch of Secret Lives of blank nature documentaries. These are great for kids. Science, Space, and Tech. Infinite Rainbows. Wait a second here. I mean, it's worth signing up for CuriosityStream just for Infinite Rainbows alone. How did I not know about it? It's only 22 minutes long. In the time span of one single Coding Train Coding Challenge, you can watch an entire documentary about what exactly are rainbows. Learn the science of. I'm sorry, this live stream is over. It is done. I don't know if the music is playing. I'm out of here. I'm going to watch this right now. But if CuriosityStream isn't enough, with this special one-time, well, it's not exclusive, 42% off discount, you also get access to Nebula. Let me sign in here. Nebula is a streaming service created by creators, YouTube creators. Hopefully many of you might recognize many of your favorites here. Not Just Bikes is new to CuriosityStream. I'm sorry, new to Nebula, and I've been really enjoying Not Just Bikes, even though now I live somewhere where I have to drive everywhere. NerdSync is great. All of these wonderful channels. You can watch all of the videos from these YouTube channels on Nebula with no ads, no sponsor segments, and many of them have extended versions. This is something I'm hoping to get into in 2022, so you could sign up now. The other thing about it is there are a ton of originals. So if you look at the Nebula originals, You can see different kinds of video content that you can't find. Look at this, next, especially if you're in gaming, next level world building, why games are better than movies, is a wonderful Nebula original series. None of these are only available through Nebula. And I'm going to take this from Renee Ritchie. I just bought a dongle yesterday. I needed a dongle for one of my laptops. It cost more than an entire year. It's like less than $1 a month for both CuriosityStream and Nebula for the whole year. It's $11.59. If you just sign up through this link, it lets them know you found out about CuriosityStream and the Nebula bundle through me. Helps the coding train out, gives you access to all this wonderful content, supporting educational content creators. So I hope you will consider it as something that you think about doing for your streaming and entertainment and education needs for 2022. I don't know what your New Year's resolution is, but my New Year's resolution is to watch more wonderful YouTube educational content creators on Nebula. All right, let's check in back to our training. By the way, the link is in a pinned message in the chat if you're looking for it. It's also in the video description. Okay. So this is presumably the new model was trained, got down to a loss of sorry for all the scrolling, 0.644. I'm going to refresh this page. Weird. I'm like suspicious that my code isn't working because I deleted all of the, let's go back to the random noise. So first of all, let's just check here. Oh, wait a second. No, public, yeah. This is the model from 12:16 p.m. That's the new model. This project, I'm not making any progress today on this project, which is very distressing. I feel like it did something a moment ago, like when I switched back in. Hold on, we've got to debug this. Where's my next image? Okay, I got to go back to the sketch. Next image function. What if I go back to, who knows what the problem is? I know what the problem is. Come on, chat. Come on, you can think about it. What's wrong? What are the numbers coming out of input canvas.pixels? If it is a white pixel, what value is it? 255. I didn't normalize the values. This needs to be normalized, divided by 255. Okay. All right, that didn't seem to change anything. Okay, let's just, for the sake of argument, put in random noise again. So I am getting a variety. Again, ignore the fact this is, and the, I times 4, that's right? Pixels. Should I give it, it's not in the draw, let's check the input, all right. But, I mean, let's just make sure. It's continuing to run and make new input. Whoa, no, that's right. 56 by 56, 3136, okay. But like, bunch of zeros, yeah. I mean, this looks right. All right, let's try, like, why is the model not able to give me a range of sizes? It was not having that problem in the version that I made where I was passing Perlin noise into it. And look, it's like, what's it? It's doing something. Okay, use the mouse click to switch between square and circle. Am I getting alpha? I don't think I'm getting the alpha. I times 4 should be the R channel. All right, this is a good idea. So if mouse is pressed, draw a square. Otherwise, draw a circle. Okay, that's definitely something. Is the scale wrong? The mod, is it map? Oh, no, but it's symmetrical. It could be that I'm not reading the pixels in the right order. No, it's totally symmetrical, so I don't think that should matter. All right, here's the thing that I could try. Let's go back to our model. Let's look at, okay, so let's think about the model architecture for a second. Yeah, Mini Jimmy's saying accumulate the RGB and divide by 3. That shouldn't matter. The mouse mapping seems a little wrong. Yeah, I don't understand. So hold on, let's do this without the mouse mapping just to be more consistent here. Let me go here and let me say diameter. Let me make diameter a global variable. Start at the smallest, and then where do I set it? Yeah, and then I'm going to say just have it cycle back. So I'm just going to have the diameter cycle automatically. It's weird. Like this to me, like the fact that it's not changing at all makes me suspicious that I'm not doing something correctly. Because in the neural network, right, like in the output folder, in my test images, I am getting really, right? This is what I'm getting when I'm testing it. So like, why is P5 not doing this? So this is why I'm suspicious, because the model otherwise is performing as expected, just not when I bring it into P5. So I feel like maybe the way that I'm drawing these images is somehow wrong. All right, I have another idea. Just bear with me for a second. Let me take a training data image. Oh, this is, no. Let me take 10 images from the training data. And let me put those in a folder called data. We're going to figure this out. Okay? So now I am going to Joseph asked, when you were using noise, were you using the noise value or the pixel value? Oh, I was definitely using the noise value. Hold on. Let me add preload. So we're going to call these test images. Test images index I equals load image data. What are these called? Square I dot .png. And I need to use the backtick. And this should be number format 4. And then I need a loop. And you have 11 for some reason. Okay. So now, let's just, for a second, take this out, all this out. I'm going to draw image, test images 0. Now again, I'm not, okay, so let's take a look at this. Whoa. Oh, you know what? There's a little bit of an issue here. I'm worried that I wasn't refreshing the code. Hold on. Don't worry. Okay. So this looks better. Let's get rid of this. Now, function mouse pressed. Let's have a test index equals 0. So this is test index, and then test index plus plus. Okay, that's the first image. Okay, see? Nothing is changing. Now, is nothing changing because I am incorrectly? I'm pretty sure that I have the cache disabled, but let me just check. Under network is what I'm looking for. Yeah, I have, this setting should stop me from caching the model file. But why? Okay, so now I'm going to do this. Let's actually load the pixels of this image. I mean, this should be this shouldn't be, oh yeah, I don't need this input canvas anymore. This was silly. Right? I can just draw that test image directly, load pixels, pixels I times 4. Okay, I'm reading the chat because, okay. So something about the canvas was wrong. Okay, I knew something was weird. Well, this is much more what I was expecting. Oh, well, boy, did I just go off on a direction forever. Why? What was wrong with the canvas? Input canvas pixels. Input canvas, draw the image. Like, what's the difference? Okay, I'll just put this back. Okay, so and now, why if I say input, why if I do this instead of the test image, the load pixel, this must be a P5 bug. This has got to be a P5 bug. Oh, this is so sad. But I guess this is good that I discovered this because maybe it would cause me some problems later. Why is the canvas, can I not seem to get new pixels from it? I mean, one thing I could try to do is recreate the graphics context each time. Still not working. Is this asynchronous or something? I commented out the update. What am I missing? Right, there's no difference here. I mean, I guess to be 100% sure, I need to draw the input canvas. Oh, but that's going to cause problems if I'm recreating it. So I have to put this back into setup. Yeah, why? Why? What? Ah! I mean, okay, let's try this. What if I were to say test image copy input canvas? I mean, I'm just like copying the image an extra time. So right, instead of using the pixels from the actual canvas, I mean, do I need to update the is it as simple as I just didn't update the pixels because I did load pixels? That could be it. Well, this works. So I like copied the pixel from the canvas into an image. But could it have been, hold on, this does kind of make sense. Right, this is what doesn't work. I mean, I have a workaround now. So that doesn't work. But what if I were to put input canvas update pixels? No. Is that the wrong place for them? I don't know what I'm doing. No. I think it's just broken. I think the input canvas is broken. So I'm going to go back to this ridiculous solution. This is working. But now I'm going to go back to this and forget about the test images. There we go. And now, in theory, it's interesting how it's having trouble distinguishing the circle and the square, but I'm not going to get too bent out of shape about that. I kind of like that anyway. Yeah, so I definitely, Eric is saying, what if you train a data set that randomly rotates the square? I 100% want to do that. So I'm just, unfortunately, like, this is like the slowest thing I'm ever because I'm running into so many small little bugs, but I have this working. So what I would like to do is I would like to add the noise. Oh my God. So just to finish, close the loop on this. And I see some comments here in the Discord chat as well. So just to close the loop on this, what I would like to do is let me add some noise. So I'm going to say, I'm just going to add 10 random dots. So let's give me a random x and a random y and do a point at x, y with the same stroke weight. So how come I don't see those? Oh, I don't need this last argument, RGB. Point, oh, input canvas, sorry, input canvas, x, y. So you can see that the noise is, I mean, this is like a sort of pretty terrible demonstration of noise. Let's do the following. Let's give it like 100 points, stroke weight. This is so silly that I have this like divided by 2 W everywhere, but let's just make it stroke weight 1. And then also we can do the stroke like a little bit lighter. Oh, I forgot to do input canvas. That's why. Input canvas, input canvas. Can I get away with like 500? Yeah. So this is what I wanted to show you. Of course, we have this weird squircle thing going on. But this is how an autoencoder can denoise. And let's try doing 1500. Right? The noise is completely eliminated, and yet I am drawing a nice circle or square. You can see it's a little bit more squarey as it gets larger. A little bit more squarey. Wizzy says, unsure what this is all about. I just got here from the quad tree. So first of all, welcome. I hope the quad tree video was helpful to you, Wizzy. What I am doing currently is I am building, and this is the diagram of it, an autoencoder in JavaScript using both Tensorflow.js and P5.js. And what I'm now demonstrating is, and Manas is saying this isn't really denoising. The model wasn't trained on it. So the way that I'm approaching denoising here is not giving it noisy images with a target output. I'm just having it learn a singular kind of output. And then if I give it a noisy image, the only thing it knows how to do is make a copy of that input with a certain kind of style output, thus removing the noise. So that's really how I think of this as denoising. So this is exciting to see. The interesting thing would be like, what happens if I let the circle be bigger than the range in the training data set? I assume it won't be able to reproduce that, but that'll be kind of interesting to see. So like, for example, right now, this diameter, its range is going up to 200. But what if I actually like let it go from 0 all the way to the full width? So you can see as it gets to 0, it doesn't know what to make of that. Oh, whoops. Oh, sorry, this should be to this, sorry. So at a certain point, it's going to get larger than any training image it ever looked at, and it's going to get confused. Let's see what happens. Yep, there, that happened right there. So it's like trying to make sense of that, but it can't extrapolate beyond what it learned. But if I were to retrain the model with images that were the full size, I'm giving it a bigger range of images now. But if you input an image of Mario Brothers, it will draw a squircle anyway. Exactly. It's going to draw everything into a squircle. And if I retrain the model, now I kind of want to just, for the sake of argument now that I understand what wasn't working, what the issue was, let me go back to the model training code. And I'm really determined to finish this project today, so I'm obviously going to go past 1 o'clock. But let me just return to this. I am curious to see what happens if I go back to mean squared error as the loss function. And let's just change the optimizer to SGD. I don't know if this should be better or not, but let's retrain the model. You can sing the model training song. Okay, so SGD doesn't seem to be, maybe I need a higher learning rate with SGD. So let's go back to, I can't remember if I specify the learning rate anywhere. I'm using a default learning rate. But let's try mean squared error. And let's see how well this does. The inside of the rectangle looks bent in this processing sketch. So I think that's just an optical illusion. I don't want to run this again, although I can without saving the image. I think that's just an optical illusion because of the rapid pace of circle and squares. If I were to change the frame rate to like 5, I don't think you would see that. Traditionally, we use noisy inputs while training model rather than just a test set. But this is perhaps the best way to do it given the simple nature of the problem. Thank you, Manas. That's a very useful commentary. All right, so what's happening next? While this is training, and let me just put this back. I want to go to the GitHub repo for this. And this isn't going to work yet because it's still training the newer model. Although it seems to have got stuck on a local minimum, which can happen from time to time. I don't know if I should adjust the learning rate. Does anybody have a suggestion? I kind of want to just run it again and see. Although it's stuck in that same spot. Where do I put the learning rate? Is that here? So let's go to tf.js. Fit. Dot fit. Callbacks, validation split, sample weight, initial epoch, yield every. Where does the learning rate get? It goes with the optimizer. Okay. So if I wanted to try adjusting the learning rate, would go here. Like this. So let's give it just curious, a super high learning rate. Oh, whoa. It found its way past that. So it just took a little bit. Okay, whoa, okay, I'm gonna let it. This looks like a much better model with mean squared error now. I'm gonna let it keep going and not worry about So I'm just going to keep this in the back of my pocket if I wanted to. I'm going to let this model finish training. The loss is like very, very, very lower than anything I've seen to date yet working on this project. And now, what I want to do is go to the GitHub repo for this. And I didn't see this one. Sorry, Mini James, but I want to look at this one. So this particular GitHub issue was filed. Has some really, really helpful tips in it. So first of all, I managed, so thank you so much to Java GT, who writes, so this is how you can access the individual layers with autoencoder.layers. So I made a little helper function to split the autoencoder by looking for an increasing number of nodes. So this is a way I'm going to be able to do that. So, but you can't just loop over these layers, adding them to another sequence. They don't carry the weights. So I solved this with another helper function that creates a new dense layer. So this is interesting to look at. I suppose I can use this methodology. And there's a lot of other helpful like tips in here about things. So that's what I want to do next. Also generating a GIF, like all this in the node program. Make sure the decoder is fed with values 0 through 1. Okay. So, but I'm going to come back to that. I want to work on splitting the model next. But where is it? Managed to get a 28 by 28 encoder reduced down to a single value. Couldn't do this at larger sizes, which worked well down to 4 variables. One makes sense because there's only one variable changing, that radius. Okay. Are we done? All right, we have a new model. Let's see how this new model looks. So this new model should be much better. Yeah, you can see like at the larger size, it's really distinguishing the circle versus square and denoising. Interestingly, at a lower size, it's having a lot of trouble. Distinguishing the circle and the square because the bends probably of the circle are obviously much less extreme. And Hamidi is doing a really great suggestion, which is what happens when you translate the input image. All right. So what happens if I'm doing too many things at once here, but I'm going to get to the latent space thing in a moment. We have to clearly make a new sketch here. What happens if I draw that image at an XY position of my own design? So let's see what happens here. So you can see as I move it around, it's confused. But when it's centered, that's kind of cool to see. You can see like if I put it over here, it thinks it's like, that must be a big square because there's dark pixels over there. But maybe it's a small one. And I don't know why I've lost the, oh, this one's supposed to be circle. No wonder. So you can see, now, what would happen if I trained it with circles and squares that are anywhere in the image? Oh, can I do that? But I want to do the latent space thing. If you use cosine annealing learning rate, you can use a high learning rate, the schedule will lower. Yeah. So I don't know that I'm going to get that sophisticated with this, but quick summary of the comment from Manas is that you can start with a high learning rate, and then over time, like as it gets closer and closer to the optimal weights, you can lower the learning rate so that it can fine tune it better. But I cannot resist. We must not stop. Let's try having this also be try having the squares and circles in the training data set be in a random position. And this has to be float because I'm not in JavaScript land anymore. Wait a sec. Something is wrong. Oh, because I'm doing center? No. Well, that should still be fine. Oh, I'm resizing it down. So this has to actually be, these values should be the actual canvas size. Yeah. All right, this is going to be really tricky. Is it really going to be able to learn this? Convolutional layers would solve this. I probably should not be trying to do this. This is just asking for trouble. But I cannot resist. And remember, my autoencoder only has 8 units in the middle. Maybe I should give it 16. Maybe for this I should give it 16. Let's give it 16. I kind of want to save that previous model in case I need to go back to it. So hold on. Model Squircle. Now, and then I think I might need to create the model directory again, but it's empty. Okay. So now I am attempting to see, I think somebody might be here that I need to speak with. Hold on a sec, everybody. While this is training, sorry, I'm just checking something here. It might just be a delivery truck, but I hear a loud noise. Oh, maybe just retrieving something. Okay. How's this going here? Oh no, this seems kind of stuck. I think with many sizes placements, you'll want a larger training set. That makes a lot of sense. The model size is less important than the data. All right, so that's a really good point. Okay, I think I need to backtrack because my goal was to demonstrate latent variables. So let me backtrack and not go down this road right now. I think I could have done like a rotation maybe would have been. So let's go back to oh no, that's wrong. So let me put it back. I had saved the model, but I realized I need to deconstruct the model. So let me quit this. Let me just start the training again. All right, let's take a look at what I want to do. So ultimately, and let's put this back to 8. I wonder if I could get it down to 4. Well, let's do 8. That's fine. Let's see if the loss does well with 4. Okay. So I'm trying to put it down to 4 just to see how we do. Oh, I didn't make the new training data. I have to make the new training data. Sorry, everybody. My brain has melted here. What is going on? Okay. Let us go back to this wonderful code here. So this is taking out the layers, creating a new layer, setting the weights. Okay. So this makes sense. I feel like there must be a way to do it. Because it's such a simple amount of layers right now, I don't know that I'm going to use this as a reference, but I think I might be able to just save those layers in a variable and do this more simply. Let's see how this training is going. Wait, what just happened? Oh, yeah. No, the images are done. Okay. I didn't take a break. That's all kind of a problem. Andrea says, those sigmoid activations seem strange. Shouldn't you have only one after the final layer? I think that's correct. Let's do that as well. Let's have all of them. Let's be able to expand it out. Only the last one should be sigmoid. Let's see how this does for us. Okay, so now just examining the code, I know I just want the last 3 layers. So let's look at this. So now what I want to write some code is create a new model with just the decoder. So I think that probably the way that I should be doing this, though, is rather than extract the layers, shouldn't I just save them as I'm going? Like, for example, what if I were to say, what if I were to create an array? Sorry for the noise, everybody. Yeah, I could do, all right. All right, so what if I'm just going to do this. Oh, yeah. I have an idea. Sorry. Couldn't I do this, and then have decoder layers, and then basically do exactly this. Decoder layers, push, yeah. Just the helicopter landing outside. Don't be alarmed. It's picking me up. I've got to get somewhere fast. All right, so I'm going to add all these decoder layers. Okay. Then I'm going to say, for let I equal 0, I is less than decoder layers dot length, I plus plus. Then I'm going to say add decoder layers index I. Okay. So now I put the decoder layers in a separate array. Then I'm adding them to the autoencoder. So this should be the same. I hate to just constantly retrain the model, but let me just make sure this still sort of like looks right. Yep, this seems reasonable. So everything is the same as it was before. Now, if I go back to this reference, I want to create a new model. So let's, it's nice to put this in a separate function, but I'm going to pull this code from Java GT and see if I can kind of unpack it, but with my methodology. So, oh, I see, but so I'm actually going to return both the decoder layers and the autoencoder as like an object, because I might want to make use of both of these. And then I can say, do this. So now I'm building the autoencoder, but saving the decoder layers in a separate array. Okay. By the way, banning, if there's like spam happening in the chat, is perfectly, thank you, Nicole, for stepping up and doing some moderation. Just gonna, okay, I don't know if it's possible to ban or not. Okay. Okay, so, okay. So now I have access to the decoder layers separately. So what I want to do here is create the new model with just the decoder. Create decoder with both the decoder layers and the autoencoder. I don't know if this is going to work. So now I just want create decoder. Is that what I called it? Decoder layers and the autoencoder. And then I can go and take a look at this and say, create the new model, the decoder, is a sequential model. Then for every decoder layer, right? This is the sort of this. I'm kind of doing the same thing. So there might be a lot of redundancy here, so we can clean it up later, refactor this later. But I am creating the decoder, creating a new model just by taking the list of decoder layers that I saved. Tsukaya Suzuki. Someday there'll be too many of these and I won't be able to do it. It's good. Tsukaya Suzuki. Welcome to the coding train. You are boarding right now. Slow down, train. We're pulling into the station and opening the door and letting Tsukaya on board. For your coding train membership, you win. Not this ukulele. It's my prized ukulele. But your very own random number. On page 163, row 8125, column 1, your sequence is, get ready, 05348. Okay. So close here. So I'm adding all of the decoder layers to this new decoder model. Then I need to compile it. I'm going to compile the decoder with the same settings that I used for the autoencoder. So let me just make 100% sure that I'm doing this correctly by actually copying this up here and just changing this to decoder. Again, any redundant code that I can consolidate and do in a better way, I will. But the issue is, I believe maybe we don't have the weights. So, oh, it's making a new layer. Why do I have to make a new layer and copy the weights? Oh, is that really? Why can't I just add the layer with the weights? Manually copying the weights. Huh. So I feel like there's a different way to do this with Tensorflow.js, but if this works, then awesome. So, sorry, I'm going to do it, I'm going to follow this way. So I'm actually not adding the decoder layer directly. I'm creating a new layer so the old layer is that decoder layer, and I'm making a new layer with the same number of units, the same activation function, and the same input shape. In theory, I shouldn't have to do that because the input shape should be inferred, and then I'm going to add that new layer, but I also need to copy over the weights. Like this. Okay. And I don't need the autoencoder to be passed in, because I thought I was going to need that to pull the weights. Please use for of loops. You know what? I would like to do that as well. Let layer of decoder layers. Yeah, then I don't need this. Much better. So this should be the function that, and again, I feel like there's got to be a different way of doing this, but I'm fine with it. If this works, great. Where I am, and by the way, I shouldn't have to retrain the model now. I should be able to just pull in the autoencoder, load it, because I have it saved. But where did I save it is the question. File, public model. So I have to do this. So, oh, the last training got kind of stuck at like not a great loss. Let's go, should I just go back to 16? Let's go back to 16 units in the center. This needs a lot of work. 16 units. Or 8. Let's go back to 8. 8 is fine. I can do 8. We're going to go back to 8. Now I've added the decoder layers. All right, and then returning them both. So now create decoder. Okay. So let decoder equals create the decoder. And then I want to save decoder. Save decoder equals file public model decoder. So I'm going to save the decoder to a different directory. Okay, everyone. Isn't there a model.getLayer method? There certainly is, Marius. So I feel like there's probably a much more proper TFJS way of doing this, but I think this should work. Let's see what happens. Unfortunately, I'm going to have to train the whole model again. And hopefully we're going to start seeing I wonder if I do need to play with the learning rate. Or is it just going to break out of this somehow? So let's take a look here. I could just load the model I had earlier. Why? Am I just too impatient and I should let it? What is the deal with it being completely stuck? Did I not put the new training data in there? Hold on. Let's make sure the new training data is in there. Yeah, that's the new training data. What is going on? Yep, this is the new training data. I'm not saving the decoder. There's a typo in the code. Oh, thank you. Well, that's good. It gives me another excuse to run this again. I mean, I'm tempted to just load the previous model I have that I know is working well, and then, but what? Let's just generate a new training data set again, just to be sure. Lower the learning rate. Okay. So to do the learning rate, right now I'm just using the default atom. So what would be a good learning rate? I'm just going to try this, 0.01. No, this is weird. The loss is not going down. Did this mess up something? It really shouldn't have. I just put the layers in here, and then I'm putting them in the autoencoder one at a time. This is not going well. Change in the activation function? I don't think so. I mean, I can put these back. Maybe it's something to do with your layers array. I know. Well, now I've got it. It seems to have caught. So all right, I'm going to go with this and let this model finish training, because now the learning rate is, and this, by the way, is now just with whatever the default learning rate is. What is it? Tensorflow.js default learning rate Atom. .00, I don't know, that's from 2018. So this is probably the default learning rate for Atom. Okay, we're still going down. Why is the accuracy 0? Let's just see how this model does. It's so hard. Oh, okay, I like this. Epoch 85. Oof. What was that? Why was that one time that I got this incredibly low loss? Whoop. Cannot read. Oh, you know what? I forgot to return it. Hilarious, but that's fine. Let's just see now. Let's go back to my P5 sketch. Why is this model so much worse all of a sudden? Okay. So look at this model. I mean, it's definitely doing something. What just happened? I see the chat going a little bit crazy. But if I go here and load model-squircle, look, what did I do for this model? This model is working so well. Like, this is what I trained, like when I trained this model, like what? What happened? I don't remember like what settings were different. Okay. This is driving me crazy. Autoencoder 256, 128, 8. 128, 256. And these are the decoder layers that I then add one at a time. Just make sure for let layer of decoder layers. Add that layer. Then compile it, mean squared error. Yeah, I don't need this accuracy metric, I guess. Just take that out. And let's just be explicit about the learning rate so I can sort of see what it is. I wonder if I got lucky with the train. I could give it more images. Let's generate another set of training images. Use all, give ReLU another chance. Okay. But I want to use sigmoid for the last one because I want to make sure that I'm bound between 0 and 1. And maybe I shouldn't. Okay. Okay, here we go, everybody. Wait, hold on. Let's just see here. This is like really awful how I have like this duplicate code, but this shouldn't matter actually though, because I'm not going to be training this model. So I'm not sure why I need this, but I'm going to, okay, everybody. I want to give ReLU another chance. Model summary. Okay. I like this idea. I can't believe that I'm going to be another one of these live streams and not gotten to the part that I wanted to get to. AutoEncoder save train model. Is this right? What you're suggesting? Oh, my. Yeah, it's completely stuck. Learning rate. Okay. Like lower learning rate? Okay. I would have thought I need to raise the learning rate, but. Like to me, I need to raise. Yeah, I could. Lower the learning rate. Divide by 10 until it works. This does not seem like. What if I have a high learning rate? Oh my God. 832 is just like where it wants to be. What is going on? But what did I do? Like, did I change something in the training data? I don't think so. Training data looks reasonable. Oh, interesting. Okay, what just happened here? No sigmoid. No sigmoid. A terrible sigmoid. Okay, wait, this is good. Hold on. But I was like messing around with the learning rate. Okay, I'll leave that default learning rate. Okay. I think we might be in good shape now, people. I think this sigmoid was not helping me. Mana says, told you. I'm sorry. I'm sorry. Yeah. In my head, because I'm doing something that's the most sort of like basic, simplistic, like demonstration, that I should go back to the classics like sigmoid. But I guess that was really standing in the way of progress here. Standing in the way of the progress. Did I tell you about today's sponsor? I'm on another hour. CuriosityStream.com/codingtrain. Are you asleep? Do you need to wake up? Has the coding train bored you? You could try watching something on CuriosityStream or Nebula for less than $1 a month for the entire year. Oh my God. Okay, we've stopped. No, it's still going down, little bits and pieces. Little bits and pieces. What did I do that one time that we got that crazy low loss? Was it just like luck? Drop the nonlinearity for the last layer. Ah, Kay Weekman is here. Probably could have saved me like at least 2 hours of wasted time. All right, the losses definitely seems to be, nope, still going down. I want to see that like scientific notation though. Then I know I'm really doing something right. Okay. Whoop. Hiccup, a hiccup. The number went up. This is very exciting. I mean, really needs some kind of like something. Yeah, if this live stream can help people fall asleep, then I think that's wonderful. All right. 256, 128, 8, 128, 256, 3136. That's right. Total parameters, trainable parameters, non-trainable parameters. Okay, we got the model summary. Might need more epochs or a higher learning rate. Well, let's just see how this, I refresh, this should be, oh no, this is still, whoa, what? Okay, this is insane. I've not seen it do this. Wait, but am I loading the correct model? Yeah, look at this crazy model, what it's like outputting. It's so funny, there was a time earlier today where my model trained perfectly. And now, what is going on? K. Weekman, this is our current setting. Oh, sorry, I'm in the wrong code. This is the current setting. Yeah, where's the noise coming from, right? Yeah, let's remove the noise, at least in our input image, just to see how well the model is performing otherwise. This is so weird. The model was trained and has some like, I think this is because of ReLU in the last, no. I mean, where did that noise come from? Where are those dots come? Why are they there? Correct. I know everyone in the chat is like 30 seconds behind me, but the left is the input image, the right is the output. And I'm not sure where this new noise is coming from. The dots are because of the ReLU on the last layer. Negative values become zeros. Oh, over 255. Okay, so maybe it's just an issue with me drawing it. I have an idea. Hold on. I think there's an issue just with me drawing it. So where am I getting the values? Predict, await, output array, output image. Render output image, fill. So let me get that value and let me constrain it to between 0 and 255. No, it's still there. It's very consistent. Relu is in the last layer. Clip the values. I thought that's what I was doing. This shouldn't make any difference. All right, what if, hold on. If val is less than, oh, wait, hold on. Get rid of the constrain. Maybe what I don't want to do is constrain. If val is less than 0, val equals 255. Let me just make sure I'm actually editing the right code. Okay. I'm totally lost. All right, try sigmoid. Okay, we're going back to sigmoid, people. So I want the last layer to be sigmoid. And I want to just say atom here. This is what I want. I want this simplicity, and this worked. Yeah. I mean, do I just need more units? Shouldn't. Why? What's going on? Like, this was working 2 hours ago, no problem. It was training perfectly, and it was reproducing it perfectly. Oh, we can ignore this nonsense. I mean, maybe I should really be controlling the learning rate. I'm reading the comments right now, and I'm appreciating them. I've got to figure this out. Shuffle. I didn't change anything. The only weird thing I did was like adding the layers through this weird other way, but I don't understand how that could possibly be different. And the model summary makes sense. I'm so frustrated. Oh my God, it's 1:40. Oh. I have a meeting I have to go to. The input is a 56 by 56 image. I had upped the resolution because why not? I could certainly lower it back down just to like, yeah, I mean, we could lower it back down and everything will run a lot faster. Let me try that. I'll make a new set of images. Stroke weight at 8. Well, there we go. There we go. So, okay. So why was 56 by 56 freaking it out so much? Like, it's really not that different of a problem to learn. I guess it's just the orders of magnitude higher. All right, well, I'm going to go with this just because so this has to change. I got to change this to 28. It should be the only thing that matters. This is done. Okay, I must have some kind of scaling thing off because I changed it to 28 somewhere. I'm not using these anymore. Where did I mess up? This is not a thing. This is not a thing I'm doing. What is going on? Are my output images correct? No. Oh no, something is totally messed up. When I changed it to 28 by 28, that's weird. Am I hard coding in? Oh, wait, no? Okay. 28 by 28. Where? Huh. What have I done? Why did I destroy everything? Look at the chat. Regenerate images. All right. Okay, okay. Did I not regenerate the images? I didn't regenerate the images? Is that really true? I thought I did. But I guess I didn't. Oh, hi, Gloria. Gloria woke up. Oh, but now I'm stuck again. Oh, no, I'm not. Okay. Okay, everybody. I forgot to generate them. Gloria, come here. Come here, girl. You need to go outside, huh? Come here. Do you want to say hi? Okay, doggo. Okay. She does not love to be picked up. Oh, no, come here. Oh, you're a good doggy. But she does let me pick her up. Okay. Oh, yes. Look at that loss function. That is a good loss function. Okay, would you like to go back down? Okay. Go back down, Gloria. Okay. Whew. God, she is shedding like crazy. Okay. Okay. Okay, well, at least this is working now. Let me put the noise back in. Although I had it working at a higher resolution, which was nicer. Oh, I'm gonna lose my mind here. Let me put the points back in. Put some noise back in. Look, and we're denoising again. And we're denoising. So now I can do the latent variables. The smooth version of ReLU is soft plus. Okay, so Simon, I see your messages about the activation function. But I think I'm going to have to investigate that. For right now, what I just want to do is see if I can get the decoder only to work. Okay, everybody? And I've got 15 minutes to do this. So first of all, did I save the decoder? Yes. So this should be the decoder. And it has half the number of parameters, so that makes sense that it's half the weights. So now, let's see if I'm going to make a separate folder called decoder. And then I'm going to take index.html, sketch.js, put that into here. I'll make a folder called model. And that will go into here. And then in the code where it is saving the decoder, so many things here. I had so many ambitions of like some things I was going to do with this that I am definitely not getting to. If I am it should be public decoder / model. That's where it should be saved. I just changed it to that. Now I should be able to go /decoder. So this is going to break, right? Okay, this is going to break. Increase either the layer sizes or the amount of training data. Yes, 100% right. More layers and nodes, but resolution is a matter of data size. Thank you. So if I create some versions of this after today, or anybody helps with this, I'm going to get back to a higher resolution. But right now, this, I'm going to close things because I don't know where I am. This is now the decoder sketch. And the decoder sketch does not need an input canvas. It does need an output image, which I'm going to make random. And we're going to load model.json. This is the decoder. Get rid of this diameter. Now, next image is, I need to make an, it's not an input image anymore. It should just be the decoder should take, like the z vector, the latent vector, should have how many values in it? Did I end with 8 or 16? I think I did 8, right? So this middle layer, 16. I had 16. Okay, got to redo this with less. I wanted to get it down to 4, but fine, 16. So I trained the model. I have a trained model that works, so let's just find out. 16 values. Z index I equals random 1. So I'm just going to give it a random vector. And then x test. It's not really, a test isn't really exactly right. Should be just the one z vector. Predict, await, and then everything else should be the same, except I am only rendering, there's no input image anymore. I am just rendering the output image, and it should be 280 by 280. So I have no idea if I did this right, but let's see. Error due to autoencoder. So decoder, oh, this is decoder. Square was expecting the number for the third parameter. Let's get rid of doing it again. Output, print. So it got a tensor. Okay. Await output array. It got an array of values. Oh, I think maybe, no, I'm filling it at the beginning. So let's not call this for a second. W is 28. I'm going to look at the chat. Okay, so what? It's getting something. It's getting 784 pixels. I plus j times w. Oh, wait, let me, no loop, please. Sorry. Yeah, but this worked. So where was the error? And why isn't it drawing anything? Square is expecting a number for the third. Oh, does W not? Oh my goodness. Ah. So first of all, this. Sorry, everybody. I forgot about. It's just that. Okay. Boy, tiny little mistake there. So now we should actually be able to, all right? So that's one image I got from the model. Oh. Am I supposed to put a weight here? I think I might have killed this. let's take out that print. Oh, I still have some other crazy console log. So I would have expected this model not to produce such like fuzziness. But let's just out of curiosity, if I give it like all 0.5, yeah. Oh, but this is, the input is like part of, could it, am I like, oops, no. Interesting. So the question is, did I make a mistake somewhere? Yeah, right, okay. So I guess I can't really, I'm not really going to be able to sit on to saying this generate, just using the you have to reparameterize the latent vector. So I was going to just make sliders. So my plan was this follows. So take a look at this. Sliders. Push. Create slider. So the range should be between 0 and 1, starting value of 0.5, and an incrementation value of 0.01. And then what I wanted to do is have this do sliders, index I, value. Output image not being defined. What did I do here? Line 34. What did I mess up? Oh, did I lose that? Must have lost that by accident. No? Oh, let sliders equal an array. Oh, not sliders index I. Sorry. Okay. So I want to get this down to many fewer than just do like 4. And then see what I can see, oh, this makes it more square. Square to circle, this parameter. Yeah. I know I need to use a variational autoencoder. I just thought maybe the scale of ReLU is unbounded. Yeah, so should I change that to sigmoid also? Would that help? Or, like, should I let them, like the other thing I could do is just let the sliders have like a really higher range. Whoops, I keep doing this. Right? I can get all sorts of interesting stuff. All right, so I'm going to try the following. And I realize I keep running this by accident, so I'm going to let this run again. And I'm going to go back to my model. And I would like this. First, I would like this. Let me get this down to 8. I kind of want to make this 4. And then this activation should be sigmoid, meaning these 4 units coming into here. And I could add more layers, but I don't know that I really need to. Will be between 0 and 1. Yeah, and I could look at some of the compressed images to see some values, yeah. But let's try this. Okay. I'm stuck at a loss. Oh, so close, so close. Lower latent space. I know would give worse results. I just don't want to have so many sliders. Yeah, it is a good result so far. So is it going to help at all if I add some more layers? Increase the training data size. Oh, wait. Oh. I just wasn't patient enough. It like was stuck and then it caught. Okay, hold on. Let me undo let me undo that last little extra thing I added. Okay. Now, go back to the sketch. And it's still 16. It's still 16, but I used sigmoid. Yeah, this is much better. It's just too many latent. There we go. So I'm able to control all the different variables. And I can kind of try to figure out which ones do which. I'm trying to figure out how to make. Whoa. And there certainly is some extra weirdness here. Anyway, this is exciting, but I really want it to be like 8. So what if, let me just, it's 2 o'clock, so I've got to be done. I can't believe how much time I spent doing this. But this will be my last attempt. I'm just going to like pump it up a little bit. I don't know that this matters. I'm going to give it an additional layer with 64. I'm going to keep the 16. I really think I should be able to get it down to 4. Then I'm going to put it down to 4 and make that sigmoid. Then I need to add back in a 16 and a 64, right? And should I make many more training images? Is that going to help me? Like if I make 2100, I'm going to double the training images. Let me try 8. I really want it to be. All right, let's do 5100 images. I'm going to get it down to 4, and I'm going to let it train for 200 epochs. 200 images. So this has to be 5,000. I know I need to make the images. And 5,000. We run this. I could also constrain the squares and circles to be less. Yeah, so Flubby, everybody's telling me this really good suggestion, which is to pass images through the encoder and look at latent vectors, because that would certainly help give me a sense, and that's a very important analysis that I could do. Right? 2 should be enough. 1 for the type of shape and 1 for the radius. Oh, wait, this is going to take a while. I'm still just generating the training images. Let me tell you about today's sponsor, CuriosityStream. Are you still watching this? Have you been watching this for 3 hours? I can't believe how much time I'm spending on this autoencoder. I hope that this will add to my life in some meaningful way. This has got to be the last attempt. And now that I have a model for this, I can off on my own, and I'm going to push all this to GitHub. All of you can try tweaking this in different ways and let me know what configuration, architecture of the model, how many units you're able to get them to, what I'm missing here. I will accept pull requests because this is my last live stream. One more line needs to be modified from 1,000 to 5,000. Okay, where's that? I think I got both of them. Oh, is it where I'm loading the images? No. I think I'm good. I think I'm good. Yeah, think of how many eternal rainbows you could all be watching. Has anybody signed up for CuriosityStream and watched the rainbow documentary? You could have watched it like 10 times. CuriosityStream / coding train. Okay. Let's try this. Okay. Patience, everybody. Line 17. Oh, thank you. Got it. Oh, this is going to take a long time. Come on, lower that loss. You can do it. Lower that loss. Oh. Oh, yes. Yes. Oh, I like that. I like that. Oh my God! Somehow I signed up for 200 epochs of this. Yeah, so more data was clearly something I needed to do, I have a feeling. I also added more layers. How long is it taking? 3 seconds per epoch? So I got like a little bit more, so I got like 600 seconds left to go. It's 10 minutes. I mean, I'm not going anywhere. Oh, this is just the last live stream related to this AutoEncoder Decoder project. I mean, I'll probably come back to it if I'm being perfectly honest. Yeah, I've got a really nice GPU sitting over here on the machine I'm using to stream. Well, the point of doing this was just like little bits of data. Oh, that is a beautiful loss. As soon as that scientific notation comes in. I definitely do not need 200 epochs, but I'm afraid to stop it. Oh yeah, everybody, while this is training, you should sign up for the 1-year Curiosity Nebula package. It comes out to less than $1 per month. I'm not talking about less than $1 per day, per week. It's not like less. What is it like? There used to be these ads that are like less than the price of a cup of coffee per day. But no. Like by the way, a coffee at the local coffee place, very expensive. Two cups of coffee for the entire year. There you go. 2 cups of coffee. You know, I get the oat milk, which costs 50 cents extra. And then you could just watch this documentary about rainbows, which is 22 minutes long, over again. And you could tweet at me and say, thank you so much. Thank you so much. I watched the rainbows over and over again. Like the Mark Edward ad. I haven't. So my battery died, Simon. Wait, no, it's back. Ah, PCA. Yes. Code Parade was doing projects like this. So wait, hold on. Let me come back here. See how this is going. We're at epoch 63. Oh, why didn't I put in the lower and lower epochs? I could put in 150 epochs, run it again, but it's still going down. Let's get it. Let's let it. So Simon says, oh, sorry, I guess I could try to plug this in. Do I have a plug for it somewhere? Code Parade was doing some projects like this. The music was loud. Sorry about that. I thought I turned it down. Always saves models every 10 epochs. I know, I don't think I put that in there. I don't think I added any code to like save the model every so often. And it's not improving anymore. Oh, no, there we go. Huge jump down. But Simon is suggesting that I can use basically PCA, or principal component analysis, to sort the sliders from most to least important. If you change your clock on your laptop, it would already be finished. Don't think that's how it works. Hold on, I can send some important text messages. I'm going to be done in 10 minutes. Okay. The nice thing is it didn't get very cold in here. It's sunny out. Where's Gloria? Hopefully Gloria didn't like pee somewhere, because I haven't taken her outside in this whole time I've been live streaming. Are we? I've lost track of what the loss is doing. Oh yeah, it's going down further because I've got a if anybody could work out the sort of time travel, I mean, I just have to let it go at this point. I'll answer questions. I don't know. I could do some other work. I could tell you more about signing up for Curiosity Stream. Okay. Mark Edwards said, I just got here. Can I get a quick recap? Yes. Thank you for asking. I'm going to move over here just to like get my legs moving a little bit. So I've been building. This is now my 4th live stream. I'm building an autoencoder project, and I'm using the tools of Tensorflow.js, which is a machine learning library in JavaScript, and P5, which is a creative coding library in JavaScript that is good for like drawing and animation and images. This diagram is completely sort of like not that useful anymore, so it's me standing by it. Take that for what it is. But an autoencoder, a great summary of what an autoencoder is, you can find in this 2-minute papers, a YouTube channel. What is an autoencoder? And the idea is for a neural network to learn the like a sort of like lower dimensional representation of an image. That's a terrible way to explain it. An autoencoder is a mechanism for taking an input image and copying it to an output image, which is a very simple thing to do with just basic image processing algorithms like take every pixel, copy every pixel. But the hook here is that the autoencoder is not just taking all the pixels and copying them to the output, it's sending all the pixels through a neural network that with each layer of that network has less and less and less numbers that it's allowed to work with. So it's like an image compression algorithm and then a decompression algorithm. Can the neural network learn how to sort of encode an image into a smaller number of numbers? And right now I'm actually trying to take these images of simple shapes, they're squares and circles, and encode them down to 4 numbers. And really it should just be 2. Theory, we should be able to do 2 because there's only 2 variables. It's either a square or a circle, and the other variable is how big is it. But I'm going with 4. So I have that working. I've built all the code for it. Now I am training the model, and I just put in 200 epochs because I wanted to give it enough time to train. And then when it's done, what I hope to see, this is like an earlier version of it, is something that produces a much higher quality image than what you're seeing in terms of like it appearing to be a circle or a square, and that I only have to play with 4 sliders to kind of manipulate it. That's what I'm going for. Is there an epoch training dance? No, I'm so tired and hungry and exhausted and lost that I don't have one. But if I could get it back, it's only like, this is how I feel. This is my epoch training dance. $164. $168. Yes. So Mikhail I love this comment. I still don't get how the compression works. You've gone from shape and radius to shape and radius in a few hundred kilobytes of weights. So to be clear, I'm not actually doing anything of any utility whatsoever. I'm trying to demonstrate the concept to help my understanding of how to architect machine learning models, how to experiment with them, how to perhaps make creative output with them, and in a way, like the concepts that I'm demonstrating with this very, very basic scenario would hopefully extend, the music is fine, would hopefully extend to use of, say, something like a more, a GAN or a style GAN model, sort of like looking at how generative models work, thinking about how latent space and latent variables work. I'm hoping that this whole process could provide something of note there. But yes, I mean, I could write the code to just make the slider, to a button and a slider, and just manipulate them to get a circle or a square of a variable size. So there is a coding trained group. This is S.A. McKenzie asks, I'm sorry tell me how to fix my name pronunciation. Are you doing Advent of Code this year? Not so much personally, although maybe now I might have some time to, just on my own, but I don't think I'll be streaming it. But there is a Coding Train Advent of Code team, or whatever it's called, and you can, if you're in the Discord, somebody please post the Discord link. You can find out information about joining and having your Advent of Code contribute to the leaderboard. Kobe, who is the Discord manager, is organizing that. So apologies for not knowing too much about it, but you can definitely check into that. Yeah, so this is the older version with a poorly trained model and 16 latent variables. When this finishes, oh, it finished! Oh my God. So let's just look at this for a second. 256, 128, 64, 16, 4. 16, 64, 122, okay. That's right. Now, hopefully, oh, it's a made-up name. S.A. McKenzie says it's a made-up name. I don't know how it's pronounced. Great. My pronunciation is great. Okay. So now, if I come back to my sketch that loads the decoder only, I should be able to do this with just 4 sliders. I think that's the only thing I need to change. Let me just make sure, was this a new model from 2:16 p.m.? All right, everybody. I really should not do this. Anytime and every time I've ever played this sound effect means it's not going to work. But I'm about to hit refresh. And hopefully we're going to see a nice squircle there in the center, 4 sliders that allow me to manipulate it. Wait, okay. Reading, value, undefined. At least it was just a syntax error. Ah, I hard-coded. Latent total equals 4. Well, that was anticlimactic. Okay. I'm so excited. Oh, let me tell you about today's sponsor. Oh, no, sorry. Okay, refresh. Oh, I like it. Okay, circle to square. Okay, interesting. So how and what these variables do, your guess is as good as mine. Maybe and I think I would love to do the random walk now. But this is really everything I ever wanted in an autoencoder latent vector exploration P5.js sketch. I'm only an hour and 12. I have a meeting in 10 minutes, and I was planning to eat lunch in between this live stream and this meeting and answer all my emails and do everything else I needed to do. So I can't do the random walk part because I would be like, oh, I have 10 more minutes, I'll do it. Ah! I have to just stop. But I will do that on my own. Let me push the code. So the new things I'm adding are adjusted the data generation. I guess this I added the node the node's code now trains the model and siphons out the decoder only. I've got a new model and a new sketch. Yeah, new model, adjusted the sketch a little bit, and then there's the new decoder, and then I saved that earlier squircle model. So let me add all this. Live stream 4. And if you're wondering, oh, those models must be big. If you're wondering where you can find all this, oh yeah, it's here. So I'm accepting now pull requests on this. This was super helpful, the way that Java GT wrote an issue just to explain some improvements and some ideas. I think this project is in a place where I can accept pull requests. Again, I'm not at the moment looking to totally refactor it. I need to write a message here because I replied to this in my live stream many times. I want to thank the chief here, for this incredible refactoring and contribution. But it's too different than what I wrote during the live streams. So I would much rather link out to that. But if you can help sort of optimize the sort of architecture, the learning rate, so that I can get slightly higher resolution. I think having 4 latent variables is good. Like little design improvements, I would gladly take those. But I would very much especially love just documentation. So images, screenshots, GIF animations, explanations in the README. It's not really your job to do that, it's mine. But if you're looking to contribute, I gladly would take any form of contributions. I'm gonna put this to bed. I think I've only got one more thing on the docket for 2021. And then I'm hopefully relaunching the coding train anew in 2022. It will be the Processing Foundation end of year fundraiser. I think that's gonna happen now. Probably it's going to happen after Christmas, before New Year's. So stay tuned, sign up for the Discord. Thank you to sponsor. Please check out curiositystream.com/codingtrain for full access to over 1,000 documentaries, everything that's on Nebula, all the extra content, so many wonderful educational creators. For less than $1 a month for the whole year. It's $11.59, special 42% off discount. Check that out. And I really appreciate all of you sticking with me for this. And I will see you on the next live stream. And I'm looking forward to all sorts of new content and community initiatives. Now is the time to join the Discord. If you want to have a voice in the future of the coding train, join the Discord. I would love to see you there. Goodbye. I gotta go. I gotta have another meeting in like literally 7 minutes. I'm gonna do it from right here. Just I gotta sign out of this computer, but hopefully I won't still be live streaming by accident. It's a Zoom call. So I gotta play my outro music and all of that. Thanks everybody. Goodbye. See you soon. Oh my God. I cannot believe this day. Maybe I'll make the random walk happen just really quickly while I'm playing the outro music. That's a good idea. I didn't even find the outro music. I don't even know what the outro music is anymore. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot. Never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. This. I'm gonna say once again, here we go. Sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens. Kittens and kittens and kittens and kittens. Kittens and kittens and kittens and kittens. Kittens and Oh, my mic is still on. Thank you, Braden, for your nice comment. I just quickly adapted this to move the sliders randomly, which is sort of demonstrating a, oh yes, hi, welcome to my Zoom call. Oh, it's been 3 minutes. Okay, bye everybody. This is hilarious. I'm muting my microphone now. I'm gonna let this play for another like few seconds, just to the end of the song. It's got 1 minute and 30 seconds on the song. Bye everybody.
Over again, all sorts of text generation analysis things that I will use continuously over and over again. And first thing I need to do is, yes, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and Das Vidania.